Good morning, students. As we know that in this video we are going to study the types of motion. In the previous video we have studied what is motion, and here we will have a quick recap of the video, and then we will start the new topic. So first of all I want to ask you what is motion. So you can tell me what is motion when a body changes its position with respect to some reference point. So what is the reference point? This is one of the questions that you will ask me. Ma'am, what is the reference point? So for this, we are going to start our lesson. So okay, let me start. Now, the next is, what do you mean by reference point? As you can see, it is written, an object is said to be a point object if it changes its position by distances which are much greater than its size. So we can say that a point or some stationary object with respect to which a body continuously changes its position in the state of motion is called as origin or reference point. When we say an object is moving, it is always with respect to another object. For example, when we say a vehicle is moving on a road, it is moving with respect to the trees and poles on the road, which are not moving. But you say you are at rest or not moving while reading a book. Okay. So when you say you are at rest or not moving while reading a book, it is with respect to your chair or your desk. When an object moves, its position with respect to another object changes with time. Let us take the example of a car moving away from a building. As you can see in the picture, when the car is at position A, the distance between the car and the building is very small. As the car moves away from the building, see position B, its distance from the building increases. Another way of saying this is that when the car moves, its position with respect to the building changes with time. An object is said to be in motion if its position with respect to another object changes with time. So here you can see in this picture, this car is near to the building, so it is stationary. When it starts moving and it is going far away from the building, so we can say that the car is in motion. Building is again at its place. Building is not moving. So this is my reference point. When the car is near, we say it is not moving. When the car is moving away from the building, it reaches point B. So we can say that the car is moving with respect to this reference point. So I hope you have understood that. Now the next is linear motion or translatory motion. So yes, in the previous video we have studied that what is linear motion. It is also known as translatory motion. It can be divided into two parts, that is a rectilinear motion and curvilinear motion. Rectilinear motion means when a body follows straight line. Curvilinear motion when a body follows a curved path. That means we can say that when the body is moving on a straight path, that is called rectilinear motion. Very good. And now the curvilinear motion means when a body follows curved path. You can see the curve on the road and they are just following the curved path. They are not moving straight. They are following curved path. That is why we can say that they are having curvilinear motion. Now the next is my types of motion, that is translatory motion, straight line or curved path without any rotation. Translatory motion has two types. First, straight line, that is my rectilinear, and curved path, that is my curvilinear motions. Okay, so these all without any rotation, so they are called translatory motion. Now, the again in the next slide we can see the curved path. So this car is moving on the curved path, or we can see the example of the ball when you are throwing the ball. When you are playing the cricket and you are throwing the ball, so you can see the ball is following this kind of path, that is my curve, and this is called the curvilinear motion. Okay, when you are kicking the football, so again the football is following the curved path, so that motion is also come in the category of curvilinear motion. Again, you can see here is a curve and the car taking a turn. So in this turn, they are following the curvilinear. They are following the curved path, and it shows the curvilinear motion. So this is the curvilinear motion. It is also the part of translatory motion. Now, the next one is random motion. The type of motion in which an object does not move along a fixed path or direction is called random motion. It is an unpredictable type of motion in which an object moves in any direction and the direction changes continuously. Irregular motion of bodies changing the type of motion frequently is called random motion. The body executing random motion keeps changing its direction, speed, and the nature of motion without following any pattern. You can see in the example the honeybee, which is moving from one place to another place in a search of nectar. The honeybee is not following any particular path. There is no traffic signal or nobody is guiding honeybee that where honeybee has to go. So honeybee is moving randomly here and there. That is why we can say that the honeybee executes random motion. There is no particular pattern of moving, not a straight line or curve path. Any way you can move randomly here and there. So it is called random motion. Now, the next one is periodic motion. Periodic motion, as you can see that the motion which repeats itself after regular interval of time. That is my periodic motion. That means, first example, you can see there is a clock and you can see the minute, hours and seconds hand. And here I have given an example of seconds hand that you can take the example of minutes and hours hands also. It has a fixed time of movement. So we can say that the motion of the seconds hand is also the example of periodic motion, because after every second it changes its position. So we can say that it is also example of periodic motion. Means after fixed interval of time. Means if you are blinking your eyes after 1 minute, up, so you can say that it is a periodic motion, but it is not happening all the time, because if you will forget to blink your eyes after 1 minute, so it will come in the category of non-periodic motion. So next example is revolution and rotation of the earth. It is also the example of periodic motion, because earth also takes a fixed amount of time to revolve around the sun and to rotate on its axis. So that is why we can say that this is also the example of periodic motion, because the time is fixed. Next one is my more examples of periodic motion. So you can see the more example like the motion of a child on a swing, that is also the example of non-periodic, periodic motion. Swinging of a pendulum is also the example of periodic motion. Revolution of moon, you can give the example of any planet's revolution around the sun. That will be the example of periodic motion, because all the planets are taking a fixed amount of time to revolve around the sun. So we can say that their motion is a periodic motion. Also, you can take the example of orbiting of a satellite around the earth, because satellite is also having a fixed time to revolve around the earth. Now, the next one is non-periodic motion. So the motion which is not periodic, that is my non-periodic motion. So the name itself implies that this type of motion does not repeat itself after a fixed time interval, even though the motion of a body repeats. It can be non-periodic motion if it does not have a fixed time for repetition. If it has a fixed time, it will be called as a periodic motion. So if the motion repeats itself in a fixed time of interval, it is periodic, and if the time is not fixed, okay, so that will be called as non-periodic. So you can see the example of footballer running on a field, application of brakes in a moving vehicle, a ball rolling down the ground gradually slows down and finally stops. Footballer not a fixed time when he will run, when he will start running on the ground. Brake, it is not certain when you will apply the brake. It is There is no fixed timing, and also there is no fixed timing for the ball when it will stop, and after how many minutes or seconds it will stop. So that is why it will come in the category of non-periodic motion. Now the next one is the difference between periodic and non-periodic. So you can see the underlined and the red color highlighted words. These are the key words that we are going to use in the definition while we are making the difference between the periodic and non-periodic. So a motion which repeats itself at regular intervals of time is called periodic motion, and the motion which repeats itself but not at regular intervals of time is called non-periodic motion. Always remember, there is no difference in the definition except this not. So when you are using this not, non-periodic. When you are not using this not, it is periodic. So remember these definitions. Non-periodic motion is the motion which cannot repeat itself in a fixed interval of time. That is my non-periodic motion. Now, uniform motion. You can see a body is said to be in uniform motion. Uniform. Always remember this word. Uniform. You all are coming in school uniform. Why you are wearing your school uniform? Because you should look like equal. You all are equal in this school. That is why you are a student. That is why you all are wearing same kind of dress. That is why you're not calling it dress. You're calling it uniform because it is same. That is why we are calling this motion uniform, because the distance and the time of interval is same. So we can say that a body is said to be in uniform motion if it travels equal distances in equal intervals of time. No matter how small these time intervals may be, 1 second, 1 hour, 3 hours, 15 hours, I don't know, and you don't know. We are talking about which kind of motion. Okay. But if we are talking about uniform motion, so the distance and the equal intervals of time, equal distance in equal intervals of time, that should be there. It is very important. So if we draw distance time graph for uniform motion, then it will be straight line. How the straight line will come? Because when you are covering equal distance in equal amount of time, so the point will come here and here in a straight line, a form of straight line. So the first point will be here, the second point will be here, the third point will be here, the fourth point will be here, and the fifth point will be here. So when you will join all the points, you will get a straight line because the time and the distance is equal. In equal interval of time, you are covering equal distance. That is why each time you are covering 20, 20, 20, 20. So 20, 40, 60. So you will covering a equal distance, you will covering equal distance in a equal intervals of time. That is why it is example of uniform motion. Here I have given example of car which is running at a constant speed and covering 20 meters per second. That is why we are saying 50 kilometers per hour, 50 kilometers per minute, per second, whatever you are using. It depends on your speed, at what speed you are going. And that is why I have given you an example that this car is covering 20 meters in 1 second. So in every second the car is covering 20 meters. It is traveling 20 meters. It is covering 20 meters distance. That is why it is in uniform motion. Okay. Other examples also I have mentioned here. Movement of hands of a watch. It is also uniform motion. Rotation and revolution of the earth. Movement of the blades of the ceiling fan. These all are the example because the distance and the time intervals are equal. Now, the next is non-uniform motion. Means what? Which is not uniform. That is my non-uniform motion. So how will we define? A body is said to be non-uniform motion if it travels unequal distance in equal intervals of time. We will calculate time in the same way, but distance will be different. Distance will be unequal. Suppose first time you have covered 10, then you have covered 30, then you have covered 15, and then 50. So this is not equal in the equal intervals of time. That is why we are calling it non-uniform because the distance is different. So we can say that it is non-uniform motion. Example, if we drop a ball from the roof of a tall building, we will notice that it will cover unequal distances in equal intervals of time, like 5 meters in the first second, 15 meters in the second, and so on. Thus, a freely falling ball will cover smaller distances in the first second and larger distances in the later 1 second intervals. Therefore, we can say that the motion of a freely falling body is an example of a non-uniform motion. मतलब जब भी आप कुछ ऊपर से अगर फेंक रहे हो, if you are throwing something, if you are dropping something from the height, so it is not in a uniform motion. First, it is in a slow speed, and then it will cover a large distance. So we can say that the distance is not equal in all the intervals of time. That is why it is example of non-uniform motion. And you will get this curved line when you will plot a graph between the time and the distance. You will get this kind of graph, this curved line, that is called the non-uniform motion. Okay, so non-uniform motion is also known as accelerated motion. Now, the next is oscillatory motion. Oscillatory motion, that means oscillation, to and fro motion, means any object which is moving constantly backwards and forward, that is called my oscillatory motion. So we can define oscillatory motion, that is the motion that repeated itself again and again, over and over. Okay, so the motion in which an object repeats the same movement over and over. Oscillating motion is cyclic motion that repeats its movement based on a fixed point. So oscillation is also the to and fro movement, to and fro motion. That means anything which is moving backward and forward. So here you can see the picture in which I have shown the pendulum. It is a simple pendulum, and the dotted line is showing the movement of this pendulum. This is my pendulum, and when it is going backward and forward, this is the mean position, and according to this it is moving. If we are just pushing this pendulum, so it is showing to and fro motion. It is going backward and forward and covering equal distance. So this is my oscillation. Also, I have given example of oscillation. Another example like vibrating string of musical instrument, that is also my oscillatory motion. Movement of spring, that is also my oscillatory motion. So these are the example of oscillatory motion. Now we have discussed the types of motion. In the next video we will discuss about the measurement. Okay. Now till then, bye. Thank you.